We're going to talk about the clean architecture today. There's many ways to implement clean architecture. It's a very principle-driven architecture. It is based on ports and adapters and the hexagonal architecture, which means that it's not unique in its existence. It does things slightly differently, but I think it's important we understand some of the decisions I've made in putting together my version of clean architecture. That's not to say that it's the only way to do it, but it's how it's done currently. Definitely open to improvement and refinement. It's been through many versions of refinement over the years. It started back in, what was it? Yeah, over 4 years ago, almost 4.5 years ago. Started working with it, learned a lot after the first few implementations. Continue to learn a lot, continue to try and improve its existence. It's not a be-all and end-all. It's just it really is an architecture that allows the expression of the core principles I hold important in software development. We avoid the quote-unquote God classes, basically the classes that rule the world. I'm sure we've all seen them. They're make things difficult. It really kind of cements your architecture together when you have these really big classes. Just as an aside, not that there's a fixed number that you should go after, but when I start seeing my own classes get to 200, 300, 400 lines of code, I start to feel they're doing too much. We should be teasing out the responsibilities and focusing on being able to compose them better. And we'll touch on the solid principles, I think the real driving force behind the clean architecture, a little later in this video. And of course, architecture should ensure quality. I think quality should always be at the front of our mind. We're professionals. We're here to do a job and do it well. It's sometimes it is about getting things out the door because there's pressure or there's a critical bug. Absolutely, but those are as and when type of situations. Writing good quality code, I find, often means that we can handle change, enable teams, and avoid God classes over time. Also allows us to have lower technical debt that we manage. So what do I consider elements of good architecture? Well, first and foremost, it must be testable. I'm a big fan of TDD, or at the very least some level of sane test suite. If you're not fully on board with TDD, there are still ways of applying the TDD thinking after you write the code. TDD isn't about driving out the most elegant design. It's about driving out assumptions, the accidental complexity that creeps into our code, allows us to start making forward progress without doing tons of upfront thinking, and generally makes our code less coupled, a little bit more flexible over time. This, of course, leads into enabling technical agility. I know agile and agility are overloaded terms in this industry, but for me, if you don't have a code base that can respond to the needs of business, you can do all the sprint planning and story pointing you want, but it isn't going to change some of the fundamental issues that you're going to be facing. I think this leads on to the fact that architecture generally is the things that are hard to change. Often we use the word architecture to describe design. A lot of what we do is just design. Architecture are the big parts that we can't easily move around. An architecture that enables agility is one that's independent of frameworks to within reason. It's independent of the UI and independent of the database, whether that's a text file or a relational database or Mongo or Elasticsearch. We should be able to swap those components around easily. Meaning the changes are easy to accommodate. Recently I had a project where I needed to swap out some DB stuff for Elasticsearch. Because I was using the clean architecture and relying on repositories, it was actually really easy to do. I did it in less than a day. And half the time was building the code to blast the data into an Elasticsearch index, not actually dealing with the nuances of detangling database access from the rest of the application. It should be easy to deploy and easy to implement. Now, obviously easy is a subjective term, but at the end of the day, Deployment should be able to be scripted, automated, click of a button, things we consider best practice these days, easy to implement, being obviously once you've got an understanding, the pattern should be clear, visible, and simple to follow. Now just a brief history of, well, kind of the design principles driving clean architecture, or at least the design principles I feel are driving clean architecture. And then we'll look briefly at other patterns like the layered architecture, the one we're probably all most familiar with. MVC or MVX, MVVM, all kind of fit into that rough MV pattern. And then the most popular and probably, I would say, least understood, microservices. Now, I say least understood because before microservices, there was SOA. Service-oriented architecture. Now you might be saying, well, those two are very different. Actually, they really weren't. What we did wrong with SOA is we tried to make these really big, coarse-grained services to rule the world. When in reality, we should have been making a lot of little tiny services with an outer API that's more coarse-grained, consuming those inner services, which in a moment we'll find out is pretty similar to how microservices, well, it's believed microservices should be implemented. I say microservices because, once again, that's kind of a more principle-driven term. I mean, there are some tangible components there that we could talk about that microservices should express, but I've seen very large companies claim they're doing microservices when they've got a whole workflow engine built around 6 services. I would not say that's microservices. I'd say that's falling into the same anti-patterns of the SOA days. But that's my opinion. I am not the be-all and end-all to this. I just, try to apply concepts the best I can. So let's talk briefly about the solid principles. I'm not going to dig too deeply into this because it's very likely during other deliberate practice sessions we're going to actually unpack each one of these principles in far more detail with examples, with conversation, because everyone I've talked to, and I've talked to hundreds of people doing various training courses on this, there's generally a slight difference in how these principles are received, especially the single responsibility principle. You can really pull this out to some extreme academic sense. Generally, I think pragmatism is always the winning approach to these types of things. So I've got one sentence descriptions here to kind of just gain some alignment on what each of these principles would mean. Single responsibility, a class should only have one reason to change. And by that, it's doing one thing. All the methods in there are cohesively aligned to a singular concept, and that should be expressed in the name of the class. So if the class is doing things like taking user input from a console and saving some stuff to a database, that's likely at least 2 responsibilities, maybe even more. And I find this is a principle you really need to work with and refine over time because it is a very kind of more artistic feel to it. It sounds like an engineering principle, but I find development to be kind of a mix of creative and engineering disciplines. I'd say if you're too much of an engineer, you'll probably favor things a little bit in the extreme that might make things a little more rigid. If you're too much in the creative, you might not quite have enough structure to keep things coherent and easy to change. Open closed. This one's probably one of the more difficult ones to get your head around. The reason being is that you shouldn't really be changing the guts of a class, module, or function once it's been written, but you should be able to extend it, which means that you can build on it without using inheritance. Here's a key. Here's a very big key here. Open close does not mean inheritance. It actually means composition. When by composition I mean using patterns like the decorator pattern, where I consume an existing class inside of a new class. I may use most of its functionality and add a few things I need changed in the decorator. So really the concept here is that we're able to build new functionality simply by rearranging the order in which code's put together, or creating a new piece of code that consumes existing code with the modifications required. I can't say that you're ever going to have a perfectly open-closed system, but it's a principle. It's something we drive towards. As with principles, there's always tensioning between the various trade-offs and directions we want to go. Then there's the Liskov substitution principle. This one is, I'd say, highly related to the open-close, and the simple fact that a lot of people misuse inheritance to represent Liskov, when Liskov is generally better represented through an interface. I say generally, because as you'll find, I like to say, there's always an exception to every rule. Now, I definitely don't think that you should never use inheritance, but I think it is used too much of a go-to, kind of concretizing us into some kind of structure that's not easy to evolve. So, a great example of knowing you broke the Liskov substitution principle is if you inherit and suddenly you have a method in the class that's inheriting from the base that does nothing or throws an exception. You've instantly broken the Liskov substitution principle because they're not going to behave the same way. I can't inherit from A. I can't have B inherit from A and inject B for A because instantly I have different behaviors. I cannot fully substitute them in. Interface segregation principle basically says that we shouldn't depend on methods we don't need. What does that mean? That means break your interfaces up. I'm probably guilty of not doing this enough, and I think it's really easy to do when you're a small team and you've got a lot of shared code, and I'll just attach this here for now and put that there, and before you know it, you got an interface that's probably doing a few things. It's kind of like single responsibility for interfaces, so break it out. If I wanted to go to as extreme as I've got an interface for writing and I've got an interface for reading from a database. I think that's a little bit far, but the CQRS pattern is kind of in that line. So basically, I shouldn't be depending on a whole bunch of things I'm never going to use. I should be able to just inject the version of the interface I need for those methods and carry on. And probably the one that's changed how I do development the most, mainly because it wasn't really a concept back in the day, is dependency inversion. So the idea here is that high-level code shouldn't depend on low-level code, or they both should depend on abstractions. So classic example, using interfaces for things that are passed into the constructor or consumed by classes rather than the concrete. This is generally achieved with some kind of IOC container, allowing me to say, oh, this thing implements this interface, and this is what it looks like, and here's its dependencies it needs to go. It really allows you to do things like create an in-memory version of a repository, get things working, swap that out to the real implementation. You can do a lot of development without worrying about too much of the nitty-gritty details that way, allowing you to focus on the business value and get the concept nailed down, and then distill right into the meat of the detail, that particular repository that needs to be put together. Now, obviously, if there's simple things like database stuff and you've got good migrations, go ahead, test, probably put the real one in. But if you're struggling to understand the implementation, or you're focusing on trying to flesh out other parts of the system, I think by all means this is a great way to evolve your understanding, build context quickly without getting stuck into the detail. Here's my favorite principle. I say favorite because I feel every developer to some level misunderstands this principle. If I'm not mistaken, this first surfaced in a book called Pragmatic Programmer. If you haven't read it, please do yourself a favor and read it. The idea here is that every piece of knowledge must have a single authoritative representation in the system. This is often misunderstood, that we need to remove similar looking code. Now, the thing is, we could have pieces of similar looking code that represent different pieces of knowledge. Not always, but it can happen. Maybe they're being consumed in a way within multiple functions that, there's slight alterations to the way it needs to behave. So a good way to know this is that when you pull out a method, a single sentence can describe what those two things are doing. If you need to use and or, you've missed the point. There's not a single unambiguous representation in the system. It is generally aligned to removing duplicate code, but not always. And if we pair this with the rule of 3 that says let duplication evolve until it's the third time, we start to get a richer understanding that, the rule of three says it's only after three incidents or three elements in a series can we determine what the series is, or we can basically determine what the concept is. Often developers go, oh, I think I'm going to need this, and I'm going to pull it out and make this weird abstraction here and make it do this thing, or I've got two, and I'm just so uncomfortable with the fact that there's similar looking code in two places. Live with it. I mean, especially if you're writing tests. Oh, well, maybe you introduce a bug. Oh, no. Bugs happen, but it's going to be one of the few places you could introduce a bug. And likely, if you're being diligent, I highly doubt that you're going to introduce some kind of bug. And that kind of leads on to the point that you should be constantly refactoring your code to improve it and your understanding of the system. But that's a concept we'll dig way more into when we start doing some TDD stuff during our deliberate practice. The real value in TDD is that technical agility to refactor our code, to better represent concepts, to make it easier to understand for a human being, not just a computer. So this leads us on to exploring, I guess, the architectures that came before. Maybe that's a good way of putting it. I would say this is probably one of the older ones I know of. I remember learning about this, way back in university in the late 90s, early 2000s. This was considered the standard and the best way to write code, and we must go forth and use it. Not to say that it's not a good architecture or it's not applicable in certain scenarios. The problem is it's quite rigid, and it really locks you into an implementation. Yes, it does stratify the various concerns. Awesome. That's cool. But I've been in many scenarios where I've needed to reuse key pieces of a system to do kind of one-off task or restructure things quickly for a new application. If I'd used the layered approach, I would not have been able to have that flexibility in recomposing my code quickly to get something out. I would have probably ended up duplicating or, doing a lot of refactoring to get things into a state where it can go. If you're in a hurry or, if you're absolutely certain this will never be reused, but there's nothing more permanent than a temporary fix, then, probably go ahead. But for me, not that it's wrong, it's just an approach that doesn't provide the trade-offs I'm looking for in my architecture. The advantage here is you probably aren't going to be mapping things across each of these boundaries like UI to business and business to persistence / database, because you're just going to be passing objects down and, here you go. Great, there's definitely trade-offs there. The clean architecture does have a little bit of overhead in protecting your boundaries, but protecting those boundaries, I feel, is quite key to enabling that flexibility. I've made that mistake a few times where I'm like, no, I'll just have a domain object and the UI can depend on it. Oh gosh, now this thing's got some weird properties, and I'm kind of losing the value I had from the architecture. So, typically the way this works, you got a bunch of horizontal layers. Each one kind of talks down the stack to the very bottom. They each focus on performing specific things. Requests move layer to layer till they hit the bottom, and then move their way back up to the top to be represented. The order of dependency is the order of execution. The data flows the same way. This is definitely a step forward, I think, from some of the go-to spaghetti code days of yore. But like I said, I don't feel it's best practice anymore, and it's not something that I actively encourage trying to write code to. Hence why we have clean architecture, onion, hexagonal, ports and adapters, whatever you want to call it. All of those architectural concepts are basically revolving around the ability to invert dependencies against the flow of execution. And we'll talk about that in a little bit when we dig into the clean architecture. Then there came the MVC. Now this was great for kind of the web world. Also learned about this back in the day in university. And this was probably slightly later 2000s, but I mean like 2002. That's when we talked about it. Web was just kind of getting big around that time. I mean, web had been big for a while, but it was finally getting to the point where, I think Java would come out with their enterprise Java stack 1.0 or 1.1, and these are types of concepts we were discussing then. So it allows me to separate the internal representation of information from how that information is presented to the user. So now I've got some kind of model sitting on the back end that, it's a little bit different to the view. It's not tightly coupled to the view, though often it was. So the controller takes some input and converts it to an operation or model for the view. So basically, you've got the browser. It sends a request to the controller. The controller does some stuff with that data, translates it into a model that the view can then update and sends the rendered content back to the browser. This MVX pattern, MVVM, MVVM is a nice slight improvement in the fact that this model generally is kind of what the controller should operate on. And then between the model and the view, there's a view model that gets translated to deal with particular view model concerns and certain front end pieces of logic that only really apply to the front end because they're like checking for date ranges or validating user input or those kinds of things that make sense in the view. Angular's an MVVM type. I don't think it's MVVM, but it's a similar type of concept to this MVX type of world. Microsoft named a whole framework after it, MVC. There you go, Microsoft. Way to name a framework after a pattern. Generally, over time with this, you got some kind of tangled dependency graph that's hard to unravel. Things always start off with the best of intentions, but I've never found this architecture to be clear-cut and easy to work with without a ton of policing. Not to say that there shouldn't ever be oversight in software and architecture, but I tend to favor more on the side of trust and using conversation to build alignment than being a type of micromanagement person where I'm looking at every line of code and making sure it's done accurately. I would like to think once we have a generalized view and direction we're going off after and the pattern's been put down, for the most part, we should be heading in the right direction. Obviously, there's always some kind of onboarding, gearing up time to get people to build that internal understanding that aligns to the team. But even then, I've often found that the things do just spiral out and you end up with a mess. And one of the advantages I'm trying to acquire with Queen architecture is really a specific type of dependency graph that makes it clear. It makes it hard to do things wrong. Then I'm going to kind of talk about what I would say is a slightly modified version of the MVC pattern, especially in the traditional ASP.NET implementation. So typically, you see a lot of examples for MVC, especially in the Microsoft world, that just inject a DB context or some other kind of database stuff right into the controller. You do the work there. Out pops the model, and it goes to the view, and everything's happy. Yeah, that's nice, but you're making your code incredibly large. You're not doing single responsibility. You're making it hard to change. Like if I wanted to go make that change of swapping out certain components from a relational database to Elasticsearch, I'd be doing a lot of refactoring, and potentially breaking things in the way, rather than just being able to take out the little bit of code that needs to change. I'd have to refactor everything around it, which clearly to me indicates that you violated the S of single responsibility. It's doing more than one thing. It's doing way more than one thing, especially if you just take a layered concept and apply it to the controller. I mean, instantly you've lost your layers. Okay, that's great. And then the dependency inversion here, because now I've got a repository. It's an abstraction. The controllers, depending on that repository, it could be an in-memory, it could be a physical database, it could be anything I want it to be. I've got the power of making those decisions as a developer if and when I need to do it. And the other advantage is it increases testability. I find the more you strive for the S and solid, that single responsibility, the easier it is to test things because they're doing one thing. Yeah, maybe they make use of a few other things to achieve their job, but I can mock those out, or I could have in-memory implementations. We'll get into the different types of options when we talk TDD. But generally, the architecture that's testable starts to drive towards an architecture that's easy to change. Within reason. There's always some pitfalls and caveats with testing and some more advanced things I think people tend to miss out on, like test data builders and just, builders for constructing your scenario and basically refactoring your test into reusable bits of code. We tend to potentially skip over that. Now finally, just a quick little word on microservices. So this was a graphic I found, I think, in an O'Reilly book online. Microservices are a term, like SOA was, thrown around by everybody. Oh, we must go microservices, and we must do this, and there's overheads and there's things they worry about. Not to say that microservices are bad or wrong, but I think before we make any decision to go any direction, we need to think about, is it the right decision for what we're doing? Do we have the amount of people needed to support this? And are we actually going to see the benefits? Just because we're doing something new doesn't mean we're going to do it well. In fact, quite the opposite, especially if we're just first encountering it. As I can attest to with my clean architecture stuff, like I'd say the first, probably 1.5 years, 2 years, 3 projects were a horrible mess of a learning experience. I had done everything from returning entities that relied on entity framework stuff all the way up and calling those my entities, to making a bajillion different projects to nicely separate things out, to finally kind of using the structure that I'm using now to compose things. And even then, there's been 1 or 2 niggles that I've only just now actually found a really nice solution to within that use case space as I've worked with it and kind of thought and stewed over it. So a simple microservice architecture, you've got service components. That could be an API, that could be some kind of agent that handles messages on a message bus. It could be anything. It's generally focusing on doing a very specific set of tasks or a task. You've got some kind of user interface layer, probably some kind of REST interface layer that people interact with, and then that composes those services together. That user interface could be GraphQL. That's a great way to compose things if you need to. Though the more I work with clean architecture and think about things from that perspective, the less... I think that's a lot of the reason GraphQL exists, because people still put down these really fat interfaces to kind of minimize effort without, I think, fully understanding the problem. But microservices are here. There's definitely reasons to decouple and do things this way. Being able to break things into Docker containers that have specific purposes is a great way to scale. There's definitely a scalability component that comes with this. But there's an overhead of, technically, you should probably be maintaining your own data source for each of these, which means that now you've got a message queue just for data updates and all sorts of fun stuff like that. We can have a discussion about that some other time if you want. I do have some strong opinions. I'm not saying I'm right, but I do think people generally tend to misunderstand some of the architectural concepts that microservices are meant to achieve. So why clean architecture? Why do I feel that this solves some of the great needs we have? Well, we should think about our application as a group of use cases that describe the intent, and a group of plugins that give those use cases access to the outside world. So really, we should be structuring things around the business value and the business logic, and treating everything else as auxiliary concerns, rather than trying to build things on top of a database and work our way up into the business logic. Or even worse, piling all our business logic into a database. Stored procedures have a time and place. If you've got some crazy high-performance environment, I mean absolutely insane, like you running a gambling company and it's a Durban July, even then, it will fall over. True story. Someday I'll tell you about Hollywood bets in that story. But, arguably, we really need to be structuring things so they're flexible and we're focusing on business, not technology first. So here's a clean architecture diagram. I'm sure it makes a whole lot of sense, about as much as mud does. No, actually, it is a little confusing. And I'm going to just take a moment to talk through some of the key elements here. So inside, we've got the entities. So this is the core of our architecture. These are the domain entities. These are the things that have properties and methods to operate on those properties that are core to the problem we're solving. Entities are consumed by use cases. So that means use cases know about entities, but entities never know about use cases. So as we work out, there's a natural inversion of dependencies, which kind of goes against the flow of execution. So the flow of execution is always going to come in from the outside, and the dependencies are always going to work their way. No, actually, hold on. I'll come back to that in a sec. I think I've just confused myself. So the entities worry about they know nothing about the use cases. The use cases know about entities, probably likely because they're consuming them. They generally contain things that are quite universal to those entities. The use cases are going to be things that are specific to the problem we're solving. They will likely consume entities, have some business logic sitting in there to perform certain tasks. But as you can see, they would probably take some kind of repository to gain access to the entities. They may just make entities or larger composite entities. So you may take an entity, use it inside of a larger entity that takes a few different types of things and does stuff. I can't think of a good example right off the top of my head. Well, I can, but I'm not allowed to discuss it. So I'll come back to that maybe in a minute. And then you can see the controllers know about the use cases, but the use cases never know about the controllers. The controller could be anything like a API controller or a term that you're going to apply to some way of gaining access to information, like in a console application. Maybe you've got something you call a controller, or a manager would be another term. That's a horrible term because it's very undescriptive. I suppose controller is not that descriptive, but just don't put manager or controller at the end unless you're using, controllers you have to because it's a standard. But anyway, out in controllers sit the presenters. So really, the presenters are passed into the use cases. So the presenters will push information into the use case and return information out of the use case without having a specific signature. So the controller generally news up a concrete of the presenter. The use case relies on some kind of interface to say this is the contract. So you can kind of see here the flow of control. You've got a controller and it's got a presenter, and basically that controller takes the presenter and passes it into the use case, and that use case takes data in and returns data back out. At this level, what it's passing in and out, I would say, would likely be some kind of entity. You could make a new boundary object. Well, what's coming in is probably something sitting next to the use case. What's coming out would likely be an entity. So controllers can still know about entities. And what comes out of that presenter allows us to do the transformation required for that controller, whether it's returning that data in JSON, whether it's transforming that domain entity into something that can go across that boundary out to the web or the UI. Great, we shouldn't be passing those domain entities out across the wire. They should kind of stay within that use case entity controller, kind of the blue, red, and yellow sphere. And the reason being is you don't want to create a dependency on the outside world, or outside resource that requires a specific shape to that domain entity. Transform it into something that can be sent out, just like something coming in shouldn't be a domain entity. It should be some kind of specific object for that particular boundary. I've made that mistake where I didn't do that, and it wasn't fun. It really is an important thing to do. And sitting out on the outside, what we're going to say is the least important. When I say least important, I mean these are the things we shouldn't really even worry about. Often, traditional, especially layered architecture, would worry about getting the database put together. And, this is before the days of migration, but, you'd hire some expensive DBAs to construct the perfect DB structure, build the app, find that it was all wrong, spend months or years restructuring things, and adding no value. This is really an architecture that attempts to add as much value as quickly as possible. So, arguably the gateways here could be repositories, interfaces. These are the things that are important, but aren't critical to solving the problem. They're things that we need to rely on and be able to interact with, but they're not things that we should be building the entire system around. I think that's really the value of this diagram. Another way to think about this is I've got entry points, so controllers, message handlers, scheduled jobs. So controllers, let's think of it as a typical API controller. Message handlers would be something listening to a message queue, and jobs would be some kind of scheduled job. So these are just entry points into the system, or entry points into the domain, let's say. And that domain is going to consist of entities, use cases, and interfaces, and the objects that the interfaces potentially need, especially in terms of the use cases, so the inputs. generally. Maybe the outputs, but outputs are generally entities, at least in my experience. So data flows in from an entry point into the domain. Things happen in the domain. That domain calls out to some kind of data provider, database, file system, REST API. I don't care. It's an interface. There's an abstraction there. How it's been implemented for that particular point in time should really be an arbitrary detail. Because the hallmark of a good architect is deferring as many decisions to as late as possible. Because the longer you defer them, the more information you have, the easier it is to make well-informed decisions about how you need to structure things. Allows you the flexibility of changing out the data. So basically the idea is if entities go out to the database can do all kinds of things to turn that entity around and normalize it, even put it into multiple locations in different database tables, whatever it needs to, and then it spits out one unified entity. Same thing with the file system or REST API. Take the entities in, emit the entities. That way you're not exposing any of the internal nastiness about how you're choosing to save that. I mean, a good example would be, I don't want a database. I'm just going to use a file system. Great, cool. I've got an interface. I've got my data provider. It's working off the file system. Oh, nope, system's growing. I really need a database now. Okay, cool. I'll go write one for a database. Done. Nothing in the domain's changed. I've just chosen to use a different data provider. And underpinning all of this is always configuration. The ideal state of kind of open-close principle is literally being able to just change the behavior through configuration. Yeah, it's possible. I wouldn't say it's not a silver bullet. It's not something you should chase in detail, the only way to do it. But there's often some amount of configuration that underpins all of this, whether it's something as simple as connection strings or maybe it's some feature toggles. That's a great way to change behavior. It's also more complicated, I think, on the back end than it is on the front end. I've seen some good examples. I've seen some bad examples of feature toggles, but it's definitely doable to drive through configuration. Underpinning this communication, talked about the presenters. So the entry point's going to have a presenter that talks through the domain, and the domain's going to talk through repositories or gateways. I think repositories are all familiar with, to the outside world. So always protecting this inside domain so that the outside on either side doesn't really get to inform us about how data comes back. There's always a set contract, and that's generally the entity with regards to how data moves around. So data flow, you got an entry point that makes a presenter that calls into a use case that consumes some entities via a repository that calls into a data source. So it goes down and then back up. So a better way to, I think, realize this dependency rule is to have a little example here. So in a traditional layered architecture, all the arrows would point in the same direction: entry point, domain, whatever that means, business logic, and then down into the data layer. Right now, the composition or entry point is, the composition layer is the entry point and the presenter. These are going to be two concrete things. They're going to depend on the domain. They're going to depend on those abstractions in the domain. Obviously, using IOC, we'll be able to concretize use cases and concretize the repositories that are attached to some of these interfaces. And the same thing with the data layer. The data layer has a dependency on the domain. So the domain sits at the heart, and everything depends on it. It never depends on anything. In fact, ideally, it doesn't have any dependencies. Now, the exception here is that I've created a bunch of framework around clean architecture that just avoids us from needing to type it up all the time, that we do depend on. And that's the one exception I'm generally willing to make. But your entities shouldn't really depend on external frameworks. Your data can, your composition can, great, that's where they belong. But for the most part, these really should be clean. So they're going to be the domain entities, they're going to be the use cases, the business logic, they're going to be interfaces both for the presenter and for the repositories, and they're going to be use case inputs. So you can think of these as basically three different projects you're going to have. You're going to have your web project, you're going to have your domain project, and you're going to have your data project. And we could talk about partitioning them out and following some of the higher principles of clean architecture. But if we just get those three right and understand that kind of dependency inversion, we head a long way. Now the use case inputs sit here because the interfaces for the use cases are going to need to know about them. And short of exploding this into a bajillion different projects that actually become really hard to track, this was kind of the best way I could find to structure things in a simple enough way to put it together and go forward. Now, that's not to say you're always going to have just one domain in a project. Security is a good one. It really is its own kind of domain. Auditing would be its own kind of domain. And then maybe I've got a domain for billing and a domains for sales, because billing is going to need to have a different entity for a user than sales would. Sales doesn't care about their address and credit card details, so why model that as an entity that sales needs to consume? Model as a billing entity and a sales entity, and there we go. Now we've got two different domains. Now that's a great way in theory. In practice, it probably does get a little bit more smashed together than it should, but the idea being, if we can see some really clear boundaries, we should start to explore them and try to partition out that way, or at the very least make things flexible enough that we can start to partition out into different domains. A little more on the dependency inversion. You've got an interface that a use case implements and a repository implements. So then the repository is injected via IOC into the use case that depends on that repository interface. Standard kind of inversion of control type stuff. I'm pretty sure you get that. I'm not going to go into a whole lot of detail. Some data models. So composition layer, you got your input model. So this is what's coming into the API controller. You've got a mapper here. It's going to transform that input model into a domain entity to pass into that inner domain, in this case a use case. Same thing here. You've got a data layer that's going to depend on the entities. There's usually through a repository that's there via an interface. It's also going to have a mapper. It's going to transform that domain entity into something specific to how it needs to persist the data, called the data model. And it can be a little tedious, but if you name things well, this generally is pretty simple. I don't like injecting this because then once again you're starting to kind of have a shared dependency. You're creating a single almost God project that needs to know about everything. I tend to make it per class. Composition class will have its own mapping, the data class will have its own mapping. The reason I do that is I tried having a single one, and I ended up with such a tangled mess because anything more than a trivial project, it really becomes hard to keep that separated and working well. And at least at that time, there was some funnies with the way the auto mapping worked. Yeah, auto mapping with the IOC, it just wasn't. It was a headache. It actually ended up making architecture look like a mess. So I really feel this ties back into the original essence of what Uncle Bob said. This is a dry principle gone wrong. Don't try to centralize this type of thing. They're not really representing the same concept. And if you're passing in a lot of the same stuff to the same places, maybe you need to look at bringing that into one class or restructuring things at a more of a design level than necessarily an architecture level. At one point, I was saying you could probably get rid of the mapper. That was about a year ago. I definitely like to say at least on the composition side, you could get rid of the mapper. My understanding's evolved. I would not do that these days. Definitely smash my head on a few walls with sharp, rusty nails trying to do that. So now I'm always in favor of having mappers on both the composition and the data layer side. And then one of the last concepts I really want to dig into is the power of presenters. They're kind of a funny concept, but really they rely on reference types. Woohoo, I have a reference to memory. I can change it by just knowing its reference. So the idea here is that we decouple the UI, the output, that entry point from the actual implementation down in the domain. So here in the composition, I'm going to create a concrete presenter to pass data in. It's going to have an interface, and this use case is going to return void and depend on that interface to cross this boundary. That interface is going to say what it takes in and what it returns. Voila. Cool. Now I've got a bit of business logic that's got a nice fixed contract. Now, obviously, there's a few things that may come to mind. Well, what if I want to transform things here? Well, back the slide here with the mapper. Take your output and transform it. In fact, my library allows you to take a transformation function in the constructor that mutates it from a domain entity or whatever the output is into something that the caller is going to understand. It may need things restructured. Ryan was pointing out on the call today that it's better to have normalized than denormalized data. So maybe that's one of those things. Maybe it's more denormalized in the domain, and we normalize it for output to him. Voila, the concern's addressed where it needs to be. It's not polluted across the system. It's not causing us to make design or even architectural decisions around things simply because the UI needs to consume it this way. Quickly, testing. Because it's a testable architecture, one of the ways I like to think about testing the composition layer is I've got a test server. Probably have a use case mock, because at this level, at the outer API level, I just really care. Is it doing authentication correctly? Is it is it doing authentication correctly? If it needs to do some kind of advanced error handling, is that happening? So I tend to mock out the use case in repository, because I am really looking for a typical kind of behavioral type scenario. I don't want to make real things and compose the world, because it doesn't make sense at this level. Any other things I may have, file systems, entities, that's all stuff that can be worked through just by using good testing structure. Really the presenter is going to get passed into the use case mock. You'll wire it up to return a result. Generally, you don't care, because you're testing authentication at this level and going, yep, the endpoint exists and I can call it when I'm authenticated. Those are the things I need to worry about here. Fantastic. The one exception would be, obviously, if you're doing some kind of transformation. Actually, maybe that's a good point. At this point, I was using more domain entities. So now I would say, so there's 3 tests. You need one for unauthorized, one for authorized, and then one to ensure that the structure coming out of your entry point, your API, is in such a state that it's what the front end expects to be represented. 3 tests. Unauthorized, authorized, and the right structure, right shape to the data. Testing the domain layer. There's a test presenter. It'll be the property presenter. It's really, really there mainly for testing. It can serve some purpose if you're using a use case within a use case, though I have a slightly different approach these days to doing that. We can talk about that maybe in more detail in the future. I'm calling it a saga because it's kind of from a domain-driven design concept. It's similar to the unit of work, only it's not a 2-phase commit. Instead, you specify a compensating action if one of those steps fails. I think you might see it in some of the current code. Definitely, yeah, it should be there, but it's something I probably want to walk through in a little more detail. It's just been designed to address some of the funnies with large use cases or use case within use case kind of composition that feel awkward. And that's the concept I was talking about earlier that I've just now gotten to a point where I'm like, I finally get how to put it together. But for what you're doing, you don't really need to worry about things at that level. So if you're testing, use the property presenter. New up any services you may have. There may still be some services floating around. Not everything models nicely to a domain entity. Create a repository and then use a testing context to kind of seed the context against the repository. Set up any configuration you may need. Once again, you may need to mock this out because the use case is expecting some config to be passed down. And then obviously pass all that into your use case so that it can make more, it can use scenarios without using mocks. At the use case level, I don't think using mocks are very beneficial because you're kind of, well, they are to a point, any non-critical stuff, but things that are really important, I try to pass a real repository through. I don't do that once at the beginning of a test. I hate the test setup and teardown because, well, it's indirection. I should be able to read the entire test body as a story. That's where builders and factories and just factory methods come in handy for being able to reuse things while centralizing it but still allowing me to read a story. Test setup and teardown have incredibly limited places. In fact, I've seen more test suites go into a buggy state because of their use and order of execution dependencies than I have seen them ever add any value. And I mean, that's over like 6 years plus with hundreds of people. It often just causes problems. That's why I'm really against it. But if you can make a case, we can talk about it. Over here with the entities, pullback. So basically, if you've got any methods on those entities, you should be testing them, of course, testing the various scenarios. There's some services that the entity needs. Like it probably is going to come in through a method, not through a constructor. I've seen 1 or 2 scenarios where I've had to have some kind of service for it to work well, and that's just kind of the structure I've come to. But generally, it's just set it up with the data, test that the method behaves, call it a day, carry on. So at this level, domain level, you're generally minimizing your mocking, trying to use as many live things as you can. And it makes sense because this is the domain. This is where the heart of things are. You don't want to fake too much of it because mocks can easily put yourself into a false positive hole where, it's all working. Well, yeah, because I constructed the perfect scenario and it's not actually exercising the code. And the data layer. Once again, config any services it needs. Testing DB context, the repository. So set up your DB context in memory. Pass it in the repository. Any services, I've got a time service I use just so it can be a standardized UCT type thing. And any configuration that that repository may potentially need, because it's not always just a database. Testing DB context can be a little bit more troublesome, especially when you're doing, or testing context can be more troublesome. I've got some stuff for RabbitMQ. I don't have stuff for the Azure stuff because that's just actually a pain right now, and it's not super easy to do. Try to abstract things out the best I can, but in some cases you still need to turn on the storage emulator to run the test. But generally we're looking to use as much real-world stuff as possible here. Finally, some of the issues and benefits. Well, issues is there's boilerplate code. Everything seems to have some level of boilerplate. It's not. I wouldn't say it's suitable for all projects. If it's a long-lived project and you really want to try to build an architecture that's easy to understand, easy to work with, definitely something to consider. There's multiple ways to implement. People go off and have their own ideas, and I think a lot of the implementations I've seen tend to miss some of the key points, especially around boundaries and kind of mapping objects across each of the boundaries. They tend to underplay the power of presenters or completely ignore them, which I think is sad. Benefits, it's well structured, it's modular, it's testing, it's generally independent of frameworks and tools, it's maintainable. And probably the one thing I forgot to mention is it was also known as the screaming architecture, and that's not down to how we organize the code at a layer level, but it's how we organize the code in the solution. We should be using names. It shouldn't be interfaces or data models. It should be users, and payroll and accounts and things that come from the business domain. We should always be naming our entities in code according to the business needs, not the technical needs. Interfaces means nothing to me. That's nice. It's a bunch of interfaces, but if it's like it's in a domain project under users and there's an interface for the users repository that's called iUsers. Oh wow, not iUsers repository, but iUsers. Repositories is an erroneous technical term, just like manager. Those types of terms don't add any value to the naming, and that's more of a domain-driven design concept, focusing on naming that comes from the business domain, not the technical domain. The one caveat to that is obviously if you're working with a meta domain like data, sometimes you do need to name things according to that meta domain because that is the business domain, and that's some of the situation we find ourselves in. But please, no entities, no repositories. It's just extra words for me to read. I know it's a repository based on how it's being used, and that's probably more the direction I like to try to take my code. Is it should just read. You wouldn't read a book saying, Joe, the person, says, I like to eat cake. Why is Joe the person in there? Is there a Joe the dog? Is there a Joe the snake? If there's none of that in the story, then why am I have this extra information about Joe? Joe's a character. Should I really even care at that stage if it's a dog or a snake or a person? All I know is Joe likes cake. That's the important thing. It's not that Joe the person likes cake. Maybe Joe the dog likes cake. Cool, great. Joe likes cake. I'm happy. I get it. I can dig into, unlike a story, a bit more like code, I can dig into those methods and start to unpack the meaning behind that if I have a need to really get into the detail. And maybe that comes from us being very detailed-oriented folks. It's a lesson I've had to learn to back away from the detail, focus more on the abstract and the storytelling of my code than the technical implementations. And not to say that's been an easy journey. In fact, it's one I've only really started to do in the last few years after I've had some conversations with some interesting people in this industry that really kind of changed the outlook on how I go about writing code. But anyway, we've all got our own stories, and everything's always open for discussion. Even if I have strong opinions, doesn't mean I'm right. It just means that I've got one way of looking at the world that's worked for me, and that's going to be shaped by my experiences. And we can get into the neuroscience of biases and all sorts of crazy stuff that shapes our thinking. But anyway, that's a bit off track.